you want to preserve, and still change the state of the virtual machine. Right? So now we're going to get the best script rescue disk. Now all of the full disk encryption packages have some form of rescue disk in case the boot sector is damaged or for some other reason you need to repair or decrypt their disk, the encrypted drive. Now, why are we picking the rescue disk? Well, for one, there's a better forensic outcome. Remember, well, actually, it's easy to understand. If you, from the rescue disk environment, directly decrypt the entire drive, you've never booted into the operating system again. So what you have decrypted and what you therefore can now image and present and start looking through as evidence has never been booted since the acquisition time. So you're not changing timestamps, you're not changing other stuff that you would change if you had to boot into the system first and then decrypt it. There's some other reasons too. One is there are less anti-reverse engineering techniques employed in the little decryption engine. It's a tiny little lightweight engine in the rescue disk. They don't protect it. They don't care about it that much. It's real easy to modify. And there's some limitations, too, to working in that environment. It's always a trade-off. Let's see if we can take a look, actually, at that. Everything's up and running here. All right, so here is a virtual machine. So there's a couple of bits of this demo that are like pre-baked. I've already got a virtual machine. I didn't bother creating one from a disk image. Let's first just verify that it's encrypted. We'll just fire it up. Won't take a second. Hey presto, yep. And that's not the password. Okay, so it's encrypted. Now, let's see what happens when we attach. I'm attaching a floppy drive. Usually rescue disks are ISOs, or CDs. They're designed to be burned to CDs, and in fact, that's probably the preferred method. But you can typically extract. It's easier to work with floppy. You can work with either. It's slightly easier to work with floppies. That's why I'm working with the floppy image I've extracted from the CD and just created a floppy. So here with that set to boot, this is what happens when you boot into the rescue environment. All right? You get recovery utility. Do you want to continue? Yeah, I'd like to continue. All right, it finds that there is an encrypted drive. It recognizes it. The rescue disk, in this case, has a little recovery packet on it that contains information about that installation. And it recognizes that they match. So, all right, we're ready to go. So let's just guess. In fact, I'll type guess. Oh, that's not right. I'll type guess 1. That's not right. I'll type guess 2. Uh-oh. We get 3 tries. That's going to take us a long time if we've got, as our password list right now, just one I threw together, has 10,761 entries. That's going to take a very long time. And besides, we don't want to sit here typing, right? We've got to figure out a better way around this. All right, let's go do that right now. So, what we'll do, all right, what we'll do is have to get back into the environment I was in here. Okay. Sorry about this. Okay, we can mount that rescue floppy and take a look at the programs that are on it. All right. Okay, so you've got, well, the standard sort of DOS boot disk sort of components, right? Command com. You've got rescue.rsc, which is a little packet file that is mated to that particular encrypted disk instance, and a couple of recovery programs. Well, the one that was run initially was called recovery exe. So So let's, let me just copy that. To my desktop. And then let's see what we can do with it. Let's take a look at it. Ooh. By the way, if anybody has questions that they want to fire up, I don't mind answering them in line here. Let's see if we've got this now. There it is. All right. Now all we need is IDA, our disassembler. And if anybody wants to start a stopwatch, because I did say 15 minutes, didn't I? So you can go ahead and do that. All right, so we're using IDA. I, again, am assuming most people in the room are familiar with this exceedingly excellent tool. Wow, I'm having a hard time. Let's do this, okay. And I'm very lazy. A lot of people are very lazy. I'm very lazy. I'm not going to worry about following execution flow all the way through this. I'm going to look for the string that tells me you've entered the wrong password, because I know somewhere around there it's going to have to update the count of how many passwords I've entered, so that it can then tell me to go away and drop out. Right? So the first thing I'm trying to address, so I see the string and I see where it's referenced. We go to that function. Let's actually switch. Let's move this out of the way here. So password you've typed is incorrect, right? And then right after that, you can see, after you enter an incorrect password, we increment a DI register. Then you compare that register to 3. And if it equals, or if it, unless it's less than, if it's greater than or equal to, it'll jump you out, right? So that's very easy. That's an easy fix. That's, in fact, let's I don't know, go to text view. Where are we? Okay, and I'm going to do something a little odd here just because I think it's easier to demonstrate. I'm going to open also in a hex editor side by side, even though we've got a hex view in IDA. So where are we? Let's go back. There's that. All right, we're not synchronized, are we? Why not? Anyway, well, I can tell you, let's just go back here and work on it, right? I can tell you that we are at 8E3, and increment DI, right, is the opcode for that we'll see when we go to 8E3 is, anybody remember the opcode for increment DI? Yes, 47. So the first thing we'll do is NOP that out, change that to 90, a no op instruction, which will tell the processor not to do anything. And that means the next time the counter is never going to get incremented, right? So now you've got an unlimited number of password attempts. Boom. 1 byte, change, byte patch, save the executable, throw it back. You're okay. But we want to do a little bit better. Because, you know, we saw when you type, all you see is asterisks, right? And I think we can do a little bit better than that. So what we're going to do now is find, in fact, where those asterisks are entered, right here. Now you see, you just push the asterisks onto the stack, then you call put on the screen, put char. And what we'll do now instead is, again, try to go, we'll patch this out, and instead of putting, if you'll notice in the previous instruction, what's happening is the character is being stored in the AL register, and then is being pushed into this string that's holding the passphrase, right? In this case, we're going to take the fact that the character is still in AL and push that back onto the stack, and then that'll get printed out. So again, we can actually, the really nice thing about this is we can actually byte edit in place with a hex editor and not have to do anything more complicated or elaborate. So now that's 2 instructions. It's at 884. All right, so let's go find it. 884. I hope that's these 2. Yeah, 2A, right? 2A was the... Okay, so what we'll do is the first instruction, we're only going to replace it with a single instruction, which is to basically push AX. And that is 50. So there's a single opcode there. So now let's save this file as, let's call it something else. Let's call it special. Okay. And we can close this. And then we can start putting this back into our password, into our virtual machine environment, and actually use it as the cracker we need. So let's see. Let's hope I've done this correctly. I was a little fast and sloppy there, but let's see. All right, and then I should also have a password list set up here. I do, so I'll copy password text. All right, so let's just make sure we've got everything in our little floppy environment, the little floppy image that I mounted. Yep, we've got the password text there, and we've got special.exe. Right? So now we can unmount that. Puppy. And let's go back into our VM environment and fire up the encrypted, the virtual machine based on that encrypted drive. Okay. We're not going to continue with recovery exe because we have another program. And the nice thing is it just drops you a DOS shell, right? It's a DOS bootable disk. It drops you right there. We're going to instead do special. Well, let's make sure that everything here looks good. Yeah, special's there. PW text is there. So we're going to do special exe and angle bracket PW text. And let's see what happens. So what I'm doing here is just directing a standard input, my password list, right, into as standard input to the program. Now, the one trick I have to do is the first password, or the first thing in that list, has to be a Y, because you've got to answer the question, do you want to go ahead, yes or no, right? But once you've done that, one password you want to try per line, or passphrase per line, and let's go. There you go. So now we're trying to break into this machine, and as you can see, you should be able to see, there's, oh yeah. Yeah, you can see it's all in plain text, right? We've managed to produce, and we found the password, right? Which is tester123 in this case. It's not the password in the case a year ago, but it's working. So now, what's happening is we know the password. The disk is being decrypted in a method that will be easy for us to explain when we try to take it into court. We've used, Your Honor, we use the recovery program supplied by the manufacturer of the drive, of the encryption application, to decrypt the drive. It was never booted, and this is why we have confidence of the following evidence, da-da-da-da-da, right? So a couple of little things to keep, or that would be good to keep in mind on this. Like that password list had only 10,000 or so passwords in it. We didn't run through all of them. I put it onto a floppy, right? How much room do I have in a floppy? 1.4 megs. If Another nice thing about using a VM environment is that most password lists that you're going